Hello there. This is going to be 10-3, talking about data distributions. And again, this is a review, so we're going to hopefully go pretty fast through this. We're talking about mean, medians, and modes, and ranges. I know you've learned about these over and over again, so just a review here. The mean is the sum of the values in a data set divided by the number of values in the data set. That's otherwise known as the average. The median is the middle number when you put the data values in order. And if there's two middle numbers, you take the mean of those two middle numbers. And the mode is the value or values that occur most often. You can have one mode or more than one mode, and if there's no value that occurs more than any other, then there's no mode. And then we have the range, and that's the difference between the least and greatest values in the data set. Alright, so the first thing we're going to do is just find mean, median, and mode for a data set. So we'll start with the mean here. What we're going to do is take and add these up. 2 plus 4 is 6, plus 10 is 16, plus 7 is 23, plus 5 is 28, so we'd have 28 as the sum. There's 5 data values, so 28 divided by 5 makes the mean 5.6. For the median, we need to put the data in order. So the data in order would be 2, 4, 5, 7, and 10. And since there's an odd number of values, we have a middle number, so the median is 5. And then for the mode, as you can see, there's not any... Hold on a second. You can see that there's not any data values that occur more than any others, so we would say that there is no mode for this data set. And then finally for the range, we just take the highest value minus the lowest value, so that would be 10 minus 2, which would make the range 8. So hopefully you remember how to do those for mean, median, mode, and range. Now the next thing you're going to have to look at is whether or not your data set has an outlier. An outlier is a value that is very different from all of the other values in the set. So you can see here, if we have most of the data in one area and then a much different value in another area, it's going to throw off your mean a little bit. So sometimes the mean is not the best measure of a data set. And so we have a couple problems here to kind of help us realize that. So here we have Rico, who scored a 74, 73, 80, 75, 67, and 55 on his history test. Use the mean, median, and mode to answer each question. So which value gives Rico's test average? Well, remember that the mean is his test average, so let's find the mean. Now if we add up all of those values, we're going to get 424. And there's 6 values, so 424 divided by 6 is 70.6 repeating, so we'll just round that to 70.7. Okay, so there's the mean. We also need to find the mode. We don't have a lot of room here, or sorry, the median and the mode. So let's list these in order up top here. So we got 55, 67, 73, 74, 75, and 80. Now you can see here that 73 and 74 are in the middle, so we want to take the average of those two, which would make our median be 73.5. And then for mode, you can see that there's no value that occurs more than any other, so we would have none for the mode here. So then the next question, part B, says which values best describe Rico's score? Well, we got to choose between the median and the mean. And you can see that 55 is kind of an outlier that doesn't fit with the rest of the data. So here we would argue that the median is the best choice that describes Rico's scores, because most of the scores are closer to 73.5 than they are to 70.7. Okay, so you have a few questions there where you have to choose which one is the best measure of the data. Okay, then the last thing we're going to talk about are box and whisker plots. And box and whisker plots divide the data into what are called quartiles, and that means it divides the data into 4 equal parts. So each quartile has 1/4 of the data values. There's also something called the interquartile range, the IQR, and that's the difference between the upper and the lower quartiles, so between the first and the third quartiles. That represents the middle half of the data. Now, to make a box and whisker plot, which shows how the values are distributed in a data set, we need the minimum, okay, and that's the lowest value that's not an outlier. We need the maximum, and that's the greatest value that is not an outlier. We need 5 total values, like I said, and that is the minimum, the maximum, and then we need the first quartile, the median, and the third quartile, and I'll show you how to find these. So here's our data set here. The number of runs scored by a softball team at 19 games is given. Use the data to make a box and whisker plot. So the very first thing we need to do is put this in order. Okay, so we got 3, 4, we got 2 5s, 2 6s, 7, 8, 9, 3 10s, 2 11s, 2 12s, 13, 15, and 20. Okay, now there's not really any major outliers. You could maybe argue that 20 is an outlier here, but it's not crazy high, so we'll just leave it in there. And it says identify the 5 values that are needed and determine whether there are any outliers. And like I said, you might be able to make an argument that 20 is an outlier, but we'll just keep it in there. So the 5 values that are needed, first of all, we need to find the median. Okay, well, I have 19 values here, so that's an odd number, so that's good. So let's see, 9 in on each side is going to give me 10 as my median here. And as you can see, that divides the data into 2 sets. Okay, so here's one set, and here's the other set. Then in order to get the first and the third quartile, we need to find the middle, or the median, of those sets. Now, thankfully, again, we have an odd number, so this is going to be pretty easy to find. And that's going to be this 6 right here is going to be my first quartile. And then over here, this 12 is going to be my third quartile. And then I got my min here with 3, and my maximum value here with 20. Okay, so those are the 5 values: the minimum, first quartile, median, third quartile, and your maximum value. Okay, just a hint here, any value that is 1.5 less than the first quartile or 1.5 greater than the third quartile is an outlier. So that's just a little bit of a helpful here to find outliers. Now, it's not like a written in stone rule though, because I mean, if you look here, 3 and 4 would both be outliers, and so would 15 and 20. So we're not going to be terribly picky about that. I like to think that they have to be kind of crazy big outliers to really consider them. Okay. So if I look at my data set here, I'm going to go ahead and I'm going to plot my minimum value. Now this is counting by 2s, I believe, so 3 is going to be about right here. And my maximum value is going to be here. My median is going to be at 10. I'm going to put a line there. My first quartile is at 6. and put a line there. And my third quartile is at 12, so I'm going to put a line there. Okay, so then with the box and whisker plot, what we do is we make a box out of our 3 values in the middle, and then we add the whiskers to the sides. So this would be a box and whisker plot of that data set. Okay? And that's all that we have for 10-3. Again, let me know if you have any questions tomorrow.